Hey guys, this is Mr. Lowry. This is an assignment that we started in class today and that you'll finish for your homework. It's called Proving Angle Relationships. And today we're actually going to prove a couple theorems here. So in the past week or so, we've been practicing our two-column proofs. We've done algebra proofs, and we've done some proofs with angle measurements and segment measurements. And those so far have just been practice for what we're going to do today. The whole point of an axiomatic system, like we've been talking about, is to prove new mathematical ideas, new mathematical relationships, using definitions and postulates and properties that we already know. So that's what we're going to do today. We're actually going to prove 3 theorems. And I'm going to take these one by one. I'm going to just do one at a time in case you missed class today. And yeah, here we go. So the first is the linear pairs theorem. I'm going to tell you what it is, and then we're going to prove it. Okay, so the linear pairs theorem basically says if two angles form a linear pair, then their measures sum, which means add, to 180 degrees. Okay, we've already talked about that fact, and I actually kind of, when we were talking about inductive and deductive reasoning, I actually gave you a chain of reasoning that was really similar to the proof we're going to do. Okay, now what you want to know about proving a theorem is that we break the theorem into the if part and the then part, and the if part becomes our given, and the then part becomes what we're trying to prove. Okay, so in this case here, let me zoom in a little bit. I have given if two angles form a linear pair, prove their measures sum to 180. All right. The other thing we can do when we're trying to prove a theorem is we can draw a representative figure. We can't assume too much. We basically can only assume what we're given here in the given statement, but we can draw a picture and label the picture to help us in our proof. So what we want to draw is we want to draw an example of two angles that form a linear pair. Okay. So let's do that. I'm going to go over here and just use this as a straight edge. I'm going to draw kind of a straight line here, and then I'm going to draw another line coming out of it. So this is a linear pair. Remember, a linear pair is two angles whose non-common side, two adjacent angles whose non-common side forms opposite rays. So these are two angles, 1 and 2 are angles. They're adjacent, they're next to each other. They share this side, right? This is their common side. But the side that they don't share is this one and this one. And so these two pieces right here underneath are opposite rays. So I'm going to put a couple of points on this line so that we can label these opposite rays. We'll call them A, B, and C. All right, so I didn't really draw anything that's not given here. I'm just talking about two angles that form a linear pair. Okay, there they are. I've labeled them so that I can use those labels in my proof. So from there, we're going to make our table. Okay, so two-column proof involves, of course, 2 columns, so we make a little T table here. Okay, and on the left-hand side, I'm going to have statements, and on the right-hand side, I have reasons or justifications. Okay. Now remember that when we're doing a two-column proof, the first statement is always the given, right? So in this case, the given is two angles form a linear pair. Now, since we have a picture, we're going to refer to those two angles by their names, angle 1 and angle 2. So the given is two angles form a linear pair. We're going to say angle 1 and angle 2 form a linear pair. Okay? And how do we know that? Given. We can assume that that's the case because that's the part that we're going to assume, the if part. All right? Okay, now what we're trying to do, our goal here, way down here, I don't know exactly where it's going to go because I don't know how many lines I'm going to take, but the goal is to prove this, is to prove that the measure of angle 1 plus the measure of angle 2 equals 180. So let's just keep that in mind. I'm just going to write that off to the side. Our goal is to get the measure of angle 1 plus the measure of angle 2 equal to 180. Okay? Now in order to get there, we have to use definitions, postulates, or properties. Okay? So let's just kind of chain this reasoning together. What is a linear pair? Well, I said the definition a minute ago. If you recall, the definition from your book is two adjacent angles whose non-common sides form opposite rays. Okay, so what does that give us? That gives us opposite rays. That means that we have ray BA and ray BC, and they're opposite rays. I'm going to put op rays. So there's a lot of abbreviation in proofs. Just make sure that it's clear what you're talking about. Okay, so we're opposite rays. Okay, how do we know that's the case? Is the definition of linear pair based on how it's like defined in the book. Okay, so we got opposite rays. Now if you think about those opposite rays for a minute, BA and BC, they share a common endpoint B. And so we can kind of think of this as like a straight angle where B is the vertex. So we could say that this is like a straight angle ABC and B is the vertex. So we can say angle ABC, sorry, restart over. Angle ABC is a straight angle. I'm going to use the angle symbol to abbreviate. So that's just an angle symbol right there. Okay, and that is the definition of a opposite rays. Okay, opposite rays are two rays that go in the opposite direction. So we can kind of use that idea to say, okay, B is the vertex, and we've got a straight angle here. All right, so we're just chaining some reasoning together. Okay, so if we know that we have a straight angle here, then we know the measure of angle ABC is equal to 180 because that's what a straight angle is. All right, definition of straight angle says it's an angle with a measure of 180. So we're just chaining a bunch of definitions together. Okay. Now let's talk about the relationship between angle 1 and angle 2 and angle ABC. Okay? If I take angle 1, whatever its measure is, and I take the measure of angle 2 and I add those together, that has to equal the measure of angle ABC. That idea is called the angle addition postulate. Right? If we have two angles that are like adjacent and they form a bigger angle, then the measurements of the two small ones have to add up to the measure of the big one. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. Okay, that is the angle addition postulate. Okay. And now notice that we can do a substitution, right? We've already said that the measure of angle ABC is equal to 180, so I can just take this piece and replace it with 180. Remember, whenever we replace something with what it's equal to, we call that substitution. And that's actually what we wanted to prove, right? We wanted to prove that the two measures sum to 180. If these two angles are linear pairs, then their measures sum to 180. And there we go. Okay, so that was substitution property of equality. Okay, so that's your two-column proof of the linear pairs theorem. We did that in class, so if you missed that, you can take that, kind of follow that reasoning along. We are actually going to use this idea later today in a proof. So this is an important idea to have before we move on. Okay, in the next video, I will do the congruent supplements theorem, and I'll walk you through that, and we'll talk about what a flow proof is as well.